3, trigonometry, is dealing with the exercise in just 2.3, okay, called related angle. Now I will cover in on the tape and talk about some part of the other parts of the chapter, but this is what chapter 2 is all about in terms of related angles. So let's look at the first example. Now please, again, I know you get tired of me hearing me say things like this, but again, memorize this concept, and that is the related angle of an angle is how far is it from the x-axis. That's all you got to remember. Instead of memorizing all kinds of rules that some textbook about 90 degrees plus theta and 180 minus theta and all that stuff, how far is the angle from the x-axis? For instance, the related angle of 160 degrees is 20. How do we get that? Well, come up here, and 160 degrees is here. There it is. Well, how far is that to get to here? Well, it's 180 around here, so we subtract 180 minus 160, and we get 20 degrees. So that means any angle in here, you subtract 180. Any angle in here, you subtract 180 from it. All this kind of rule. Well, forget that. Just figure it out. You have the intelligence to do this without me telling you to do that. Just go find out how far it is from the x-axis. How far is it this way? How far is it from the x-axis? How far is it from the x-axis? That's the concept. So the related angle of 160 is 20 degrees because it's 20 degrees from here up to the angle. Related angle of 227 degrees is 47 degrees. Here's 180, so how far more does it take to get to 227? 47 degrees. So if you want some rules to memorize, in this quadrant you subtract 180 from the angle. Up here you subtract 180 minus the angle. Okay, if you like those kind of memorization, do it. Whatever it takes, that's fine. Just get the job done. How far is it from the x-axis? So you want to subtract it from 180 or you want to subtract 180 from it. All right, in the third case, angle of 310. Well, 310 is all the way around here. But how far is it from the x-axis? So this time we subtract it from 360 degrees to come up with that angle. So if the angle is in quadrant 4, subtract it from 360. If the angle is in quadrant 3, subtract 180 from it. If the angle is in quadrant 2, subtract it from 180. Just figure out how far it is from the x-axis to the terminal side of the angle. That is all there is to related angles. All right, now let's look at the next example. What happens if we have an angle larger than 360 degrees? In other words, if the problem gives you find the sine of 514 degrees. Well, what you do is 875 degrees is really saying, okay, we're going to go around here 360 one time, and then we're going to go 360 again, and then that's 720, so then that's how far it takes to get to 875. So what do we do for 875? Well, the related angle of 875 is 25 degrees. Oops, well, how do we get that all of a sudden? Well, here's what we do. We subtract 360 from it. That's the first time around, so subtract 360 from it, and that's 515. And then we go around again, so we're going to subtract another 360, so that's 551. So what we're saying is this angle is 155 degrees from here to here, from here to here. So how far is it from the x-axis? Well, that's 180 minus that, so that's 25 degrees. Again, comes back to the concept, how far is it from the x-axis? And if the angle is bigger than 360, you simply subtract 360 degrees from it. Keep subtracting 360 until you get to an angle less than 360. Then draw that angle and say, how far is it from the x-axis? If it's in quadrant 2, subtract this from 180. For quadrant 3, subtract 180 from it. Quadrant 4, subtract the angle from 360. All right, let's look at now what do we do about minus angles? Well, it's the same thing. How far are they from the x-axis? So minus 110 is going this way 110 degrees. Well, that's still how far is it from the x-axis, which would be 70 degrees. 180 minus 110. Okay. The related angle of a minus 240 degrees. Minus 240 degrees is that angle. Well, how far is it from here to here? That's 180. So subtract 180 from 240. So that makes this 60 degrees. That's it. That's the key. Listen, listen, listen again. Related angle of an angle is how far is it from the x-axis. Now what this is for is we're going to be able to take any angle and bring it back to less than 90 degrees, or it could be exactly equal to 90. We're going to take every angle that exists and be able to write it as an angle less than 90. And then we can do those 30 feet. We can take 240 degrees and work it as a 60-degree angle. So to find the sine of 240 degrees, we're going to end up doing the sine of 60 degrees. Sine of 60 degrees is square root of 3 over 2. Okay? That's what this is for, to be able to take large angles and bring them back to a simple angle less than 90 degrees. Okay, now let's look at a lot of examples. Let's look at 225 degrees. Okay, this is that last part on that first page of your notes. Now watch this and watch the process and learn the process and do that. Don't be trying to memorize numbers. Okay, 225 degrees. There it is. Draw it mentally or on paper. How far is it from the x-axis? It's 45 degrees. Now you say then the sine of 25 degrees is equal to the sine of 45 degrees. But wait a minute. We must put a plus and minus in front of here. This is where we go back to tape 214, first part of chapter 1. 225 degrees is in quadrant 3. Sine is y over r. Quadrant 3, y is negative, r is always positive, and therefore that makes this a minus. The quadrant that it's in is what determines the plus and minus. Okay, cosine 225 degrees is the cosine of 45 degrees, how far it is from the x-axis. Then quadrant 3, cosine is x over r. X is negative, r is always positive, so this is negative. Tangent of 225 degrees. Tangent of 45 degrees. How far is it from the x-axis? Plus and minus. Tangent is y over x. That's negative over negative, so that's positive. Cotangent, same sign as the tangent, remember, because they're reciprocals. Secant of 225, secant 45, same sign as the cosine, negative. Cosecant, same as the sine, negative. All right, now let's finish them off with numbers. Now we go back to sine of 45. Oh, there's that triangle. 1, 1, square root of 2. It's a minus from the quadrant. Sine of 45 is 1 over the square root of 2. Cosine of 45 minus 1 over the square root of 2. Tangent of 45, 1. Side opposite over side adjacent. Cotangent then is 1. Secant is the square root of 2, negative. Cosecant, square root of 2, negative. That's all there is to that. All right, so let's turn the page of notes and look at a bunch more examples. All right, now let's look at 210 degrees. The first one on the back page, example number 2. 210, okay, so we need to sketch it so we know where it is. 210 is here, which means what? 30 degrees. So the sine of 210 is the sine of 30 degrees. Now, plus and minus. Well, quadrant 3, sine is y over r. In quadrant 3, y is negative, r is positive. Therefore, the answer is a minus. Then 30 degrees is where we go draw our triangle. 1, 2, square root of 3. 30 degrees, side opposite over the hypotenuse. And you get the answer. So here's how we put all this together. This chapter and chapter 1. Related angle. We change sine of 210 to the sine of 30. X-axis. We then do plus and minus by the quadrant in terms of y, x, and r. Then we do the sine of 30 degrees by the special angle triangle, 1, 2, square root of 3, and we get that. That's how it all comes together to do that. All right, cosine of 210 degrees. Cosine of 210 is cosine of 30. How far is it from the x-axis? Positive or negative? It's in quadrant 3. Cosine is x over r. That's negative over always positive, so that's negative. Cosine of 30 degrees is side adjacent over the hypotenuse, so it's a minus the square root of 3 over 2. All right, tangent. Tangent of 210 is tangent of 30 plus or minus. Tangent is y over x. Quadrant 3 is negative, negative, so that's positive. So the answer is a positive. 30 degrees, tangent is 1 over the square root of 3. That's how it works. Okay, let's look at the next example of minus 210. Now what I do this one for is to get across to you that the minus in the final answer comes from the quadrant. It has nothing to do with whether this starts out with minus or plus. So let's do a minus 210. It's still the sine of 30 degrees. How far is it from the x-axis? 30 degrees. Okay? Now, quadrant 2. Sine is y over r. Positive over positive. Therefore, this is a plus. 30 degrees, 1, 2, square root of 3 is 1/2. So the answer is a positive. Here's a negative answer. Comes out to be a positive answer. Cosine of 210. Cosine of 210 is the cosine of 30 degrees. All right, so that's the square root of 3 over 2. We'll get that now. Now let's go back to plus and minus. Minus 210 is here. Cosine is x over r. X in quadrant 2 is negative. Therefore, this answer is a minus. Therefore, the final answer is a minus. The minus comes from the quadrant that it's in terms of x, y, and r. Tangent 210 is the tangent of 30 degrees, which is that 1 over square root of 3. But positive or negative? Well, tangent is quadrant is y over x, which is negative. So the answer is negative. The final answer is negative. All right, next example. 300 degrees. All right. Sine of 300 degrees is a sine of 60. How far is it to the axis? So it's 60 degrees. Sine of 60. Okay, so here's 60 up here. 1, 2, square root of 3. So the sine of 60 is the square root of 3 over 2. Plus or minus. Quadrant 4, sine is y over r. Y is negative. R is always positive. So it's a minus. So the answer is a minus the square root of 3 over 2. Cosine of 300 degrees is the cosine of 60. Cosine of 60 is the side adjacent over the hypotenuse, 1/2. Cosine, quadrant 4, x is positive, r is positive, so that's positive. So the answer is positive 1/2. Tangent 300 degrees, tangent of 60 degrees. Tangent 60 degrees, square root of 3 over 1, okay? Plus or minus? Well, tangent is y over r, y over x, excuse me, which is minus over plus, so it's a negative. So final answer then is minus square root of 3. So the final answers, these plus and minuses, are coming from the quadrant in terms of x and y's, not what the angle is, whether it's a plus or minus. Another example is a minus 300 degrees. Okay, so minus 300 degrees, quadrant 1, everything's positive. So here we have negative answers, and everything will be positive. So this will be the sine of 60, which we did in the last example, positive square root of 3 over 2. Cosine of 60, 1/2. Tangent of 60, square root of 3. But all positive because a minus 300 degrees is in quadrant 1. All right, now let's look at some other examples. All right, let's look at example 6. The sine of 120 degrees Sine of 120 degrees is sine of 60. How far is it from the x-axis? That's 60 degrees. Sine is y over r. Y appears positive, so it's positive over positive, so it's a positive. 60 degrees, here's 60 degrees. Sine is side opposite over hypotenuse, so that's a square root of 3 over 2. All right. Cosine of 120 degrees is 60 degrees. Cosine of 60 degrees. Cosine is x over r. X is negative, so this is a negative. So the answer is a negative 1/2. Cosine of 60 is side adjacent over the hypotenuse. Tangent of 120 degrees is tangent of 60. Tangent in quadrant 2 is x is negative and y is positive, so that's negative. And tangent of 60 degrees, here's 60. Tangent is square root of 3 over 1, so it's a square root of 3, negative. All right, let's look at example 7, I'm sorry. Next example, number 7, a minus 120 degrees. All right, a minus 120 degrees puts it in quadrant 3. So sine in quadrant 3 is negative because it's y over r. And how far is a minus 120 degrees from the x-axis? Well, it's also 60. So that's going to be a minus a square root of 3 over 2. Cosine of 60 is a plus 1/2. It's in quadrant 3, so it's negative. So it's negative. Tangent of 60 degrees, 120 degrees is tangent 60. Tangent of 60 is a square root of 3. Quadrant 3, y is negative, and x is also negative, so it makes it a positive, so the answer is positive. Now I want to back off and look at 6 and 7 together and look at what's written right above the notes. Right above example 6 and 7 in the notes. And I want you to see something. There's a rule that says that the sine of a minus an angle is equal to minus the sine of the angle. Now listen, it doesn't say the final answer will be negative. Okay? What this says is right here, the sine of a minus 120 degrees is, I can do that the same as the sine of 120 degrees and put a minus out in front. So I can take this minus right here and put it out front. But now, go work the sine of 120 degrees. Okay? The sine of 120 degrees is positive square root of 3 over 2. Then that minus. So we get that answer. All right, and that says, well, why didn't I just take the minus that? Well, look what happens on the next one. It says that the cosine of a negative angle is just, forget the minus, it's just the cosine of the angle. So, I'm not going to take that minus out there. I'm just going to do away with that minus and do the cosine of 120 degrees. And the cosine of 120 degrees is a minus 1/2. So my final answer is a minus 1/2. All right, let's look at the tangent. Tangent, same rule as the sine. Okay, so the tangent of a minus theta is minus the sine of theta. So what I'm saying is, if you're given a minus angle, just use this rule and then just go do the angle as it's a positive from the x-axis. All right, so the tangent of a minus 120 degrees is minus, right here, minus the tangent of 120. Now the tangent of 120 is minus, this is minus square root of 3, so a minus makes it a positive. Now what this rule is for is really is in theory and some identities and proofs that you get into other chapters. But that's what they're saying. It does not mean that just because you have a minus here, your final answer is going to be a minus. Sometimes it is, and sometimes it isn't. That minus comes from the quadrant. The final answer minus comes from the quadrant that the angle is in. I want to look at something else on all this. I kind of skipped over this till now, but I want you to see. What is the secant of 120 degrees? Well, go do this, flip it over. That's why I didn't do all 6 on these. If I want to go cotangent, go find the tangent, flip it over. If I want secant, flip over the cosine. If I want cosecant, flip over the sine. See? So if you want secant, cosecant, cotangent of any of these angles that we're dealing with in this chapter, then you go find one of these 3 and then flip it over. All right, let's look at the last example. example, last two examples on that sheet on the page 2. And tangent of 158. I'm sorry, the sine, cosine, and tangent of 158. Sine of 158, well, that's a sine of 22. How far is it from the x-axis? 22. All right, and let's see, sine, that's positive. And then you go look up the sine 22 degrees, which is 0.3746. Cosine of 158, now let's see, cosine is in quadrant 2. Over there, x is negative, so the answer is a minus. Cosine 22. Tangent 158, tangent 22. All right, now, the example number 9 on there is the sine of 305, and it goes to the minus the sine of 55, and that type thing. And you should be asking yourself, or asking me, well, why do I change this to 22 degrees when if I just punch my calculator button, I get the sine of 158 to be 0.3746, 0 point blah, blah, blah. Why do I go through all this stuff? Well, there is a purpose to it. Now, the purpose to the other ones, the special angles, is not to have to do the calculator, to be able to deal with it without the use of the calculator if you don't have it available. But when you have 158 degrees or 22 degrees and things like that, then it has to be done with a calculator. It used to be done with tables. You'd go look in the book of tables, and the tables did not have anything greater than 90 degrees, so this was extremely necessary. That's not necessary anymore except for this purpose. Let's look over here now. On your calculator, if we want to do the sine of 158 degrees, then we just hit the sine button. Okay? And the sine button is where on your calculator? TI 85 or 81 or whatever, it is usually row 5, column 2. Okay. So you hit the sine button. Then you type in, you hit the 1, then you hit the 5, then you hit the 8. So you have the sine. Whoops, you better make sure that your calculator is in degree mode. You better make sure your calculator is in degree mode. So before you start working with trig, you better go back and look at the mode of the calculator to make sure it's in degree mode. If it's in degree mode, then you type in sine 1, 5, 8, hit the enter button, and you get 0.37460, blah, blah, blah. Okay, and that's nice. And if you do the sine 22 degrees, you'll get the same answer. But here's why it's necessary for you to know this type of thing. What happens when you go the other way? What happens in a problem, and you'll have these later on, that you've got to go find the angle. It says that the sine of an angle is equal to 0.3746. How do you go find what that angle is? Well, what you do is you punch the calculator, the second button, and then the sine. Again, all this reference on my trig tapes will be using the TI 85, which will be similar to almost all other Casios and whatever. You hit second sine, which is above that is the inverse sine button, which we will learn later in chapter, I think it's 9 or 10 in this textbook. And that gives you, and then you type in the number, this number, 0.374, and that gives you, whoops, what happens? It gives you 22 degrees. Wait a minute, it won't give you the 158. So you have to know that when the calculator gives you 22 degrees, it means it could have been here 22, it could have been here 22, it could have been here 22, and it could have been here 22. So you must know this chapter to be able to work this sometimes. The next chapter in this book is law of sines and cosines, and what you're going to do on some of those problems is write down 122 or 158 degrees. Okay. So when you're working backwards and finding the angle, you need to understand, let's go back over here and look at example 8, you need to understand that that 0.3746 could come from 22 degrees or 158. So that's one reason for learning this. Okay, now let's look at the last two examples. Okay, let's look at this example. the first one on the last page, page 3. We have 3 cosecant squared of 45 degrees. Well, let's see now. That's 45 degrees. That's 1 square root of 2. And cosecant is hypotenuse over opposite. So that means that's the square root of 2 over 1 squared times 3. All right. Now let's look at the next one. Cotangent 150 degrees. Well, now this is where we do the related angle. So the first thing we do is say 150 degrees. That's here. So how far is the x-axis? So that means that's the cotangent of 30 degrees. Right? How far is the next 30 degrees? Okay. 30 degrees, then we come over and do 1, 2, square root of 3. Cotangent of 30 degrees. Here's 30. Cotangent is side adjacent over hypotenuse, so that's the square root of 3. All right, plus, let's do the third one now. Sine of 300 degrees. Well, again, 300 degrees is here, which is 60. So that's the sine of 60. So we go do our little triangle. That's 1, 2, square root of 3. Sine of 60 is a side opposite over, so this is square root of 3 over 2. All right, so that's how we do each individual one. Now let's back off and look at all of them combined and see what we have. Well, let's see. We have square root of 2 squared. That's 2 times 3. That's 6. Plus 1 square root of 3 plus a half of a square root of 3. So that's 6 plus 1 1/2 square root of 3's. Okay? And so that's our answer. Okay? All right. Let's look at the last example now. And these examples are simply, I know you can punch calculator buttons, but that's not what the purpose is. The purpose is to get across the concept of related angles, get across the concept of special ones, 30, 45, 60s, that you can do in your head and not have to deal with a calculator at different times in mathematics. So let's take this one. The sine of 240, cotangent, so on and so forth. All right, so the sine of 240. Draw the angle. It's down in quadrant 3. How far is the next axis? 60 degrees. So that's the sine of 60 degrees. And it's in quadrant 3. Sine is y over r. Quadrant 3, y is negative, so it's a minus 60 degrees. All right, cotangent 150 degrees. Cotangent 150, we just got through doing that in the last example, was the cotangent of 30. And 150 is in quadrant 2. Cotangent is x over r. In quadrant 2, x is negative, y is positive, so that's also minus. Now, minus 135 degrees. A minus 135 degrees is in quadrant 3. And that's tangent of 45. And that's cubed. Now, it's in quadrant 3. Tangent is y over x. That's negative over negative, so that's positive. Okay, minus 2 times. All right, secant of 240 degrees is a secant of 60 degrees. 240 degrees is down here. Well, let's see. Over here, quadrant 3, x secant is r over x. So r over x is negative. All right, that's how you do that by steps. All right, now the next one. Minus. Now you go to your triangle. You draw your 30-60 triangle. Sine of 60 is the square root of 3 over 2. Times cotangent 30 degrees. Cotangent is adjacent over, so that's minus the square root of 3. On the bottom, the tangent of 45, you go draw your 45, 1 square root, tangent is 1. That's cubed. Minus 2 times. Secant of 60 degrees, okay, 60 degrees up here. Secant is side adjacent over hypotenuse, so that's minus 1/2. No, I'm sorry, it's minus 2. Secant is hypotenuse over adjacent, so it's 2 over 1. Sorry. You know why 1/2 was wrong? Another reason why because the secant has to be greater than 1. That's what caught my eye first. Secant cannot be less than 1. So I automatically caught on to that and double-checked my work and found my error. Okay, then let's finish this by just the arithmetic, knowing arithmetic. Okay, top, minus times minus, that's plus. Square root of 3 times square root of 3 is 3. So this is 3 halves. On the bottom is 1 minus 2 times minus 2 is a plus 4. And so it's 5. Now it's 3 halves divided by 1/5, invert and multiply, and we get an answer of 3/10. Okay, this concludes the tape then on related angles and concept of changing an angle greater than 90 degrees back to an angle less than 90 degrees. Now let's look at the example in your notes, 300 degrees. Now we will look at this, and also we're going to look at minus 300 degrees and not only work some of the same problems that I've worked previously, but look at some other relationships. So let's look at 300 degrees. 300 degrees then would be this angle, which makes this 60 degrees from the x-axis. So the sine of 300 degrees is equal to the sine of 60 degrees. Now, quadrant 4, y sine is y over r. Quadrant 4, that's negative. Over a positive, that's a negative. And so this would be a minus the square root of 3 over 2. The cosine of 300 degrees is equal to the cosine of 60 degrees. Now, quadrant 4, this is x over r. X is positive in quadrant 4, therefore this is a positive, the cosine of 60 degrees. And so the answer is a positive 1/2. The tangent of 300 degrees is equal to the tangent of 60 degrees. And it's in quadrant 4. Tangent is y over x. Quadrant 4, that makes that negative over a positive and makes it a negative. So it's a minus the square root of 3 over 1. Now, realizing I'm getting the square root of 3 over 2, 1/2, square root of 3 from the triangles drawn for 30, 45, 60, chapter 2. I'm getting the plus and minus from chapter 1 from the quadrant. All right, let's look now at a minus 300 degrees. A minus 300 degrees would be going around this way, 300 degrees, and that makes this still 60 degrees. But notice, this is in quadrant 1. The sine of
a minus 300 degrees is equal to the sine of 60 degrees. Positive because that's in quadrant 1. So our answer then is a positive, the square root of 3 over 2. The cosine of minus 300 degrees is the cosine of 60 degrees. And it's also positive because it's in quadrant 1. Everything's positive in quadrant 1. So this is a positive 1/2. The tangent of minus 300 degrees is equal to the tangent of 60 degrees. And it's positive also quadrant 1. And so this is the positive, the square root of 3. Now again, I want you to notice some things. Let's go back and look at 300 degrees. With 300 degrees, I get negative answers on some of them. For the sine of a positive 300 degrees, I happen to get a negative answer. The cosine of positive 300 degrees, I get a positive answer. The tangent of 300 degrees, I get a negative answer. The negatives come from the quadrant that the angle is in, not from the angle. Because here I have a negative angle, I have positive answers. Negative angle, positive answers. Negative angles, positive answer. So this minus sign over here does not make this the plus and minus. The minus sign is simply telling us which way to rotate the angle to then be able to find the quadrant that the angle's in. Now, at this point, I want to break in and teach a shortcut version sometimes on more advanced problems. But it is not a shortcut version in dealing with these kind of problems. For instance, there is a statement in your book that says the sine of minus theta, the sine of a minus an angle, is minus the sine of theta. Now, I want to show you that this is true, but you got to understand what it really means. The sine of a minus theta is the same thing as minus the sine of theta. But that doesn't mean that the final answer is a minus. Let's look at this concept now on these two angles. This minus 300 degrees, and we'll go back and look at 300 degrees. Now, if I put the 300 degrees here, the sine of a minus 300 degrees is minus the sine of 300 degrees. But what's the final answer? Look at the sine of 300 degrees. Forget about this minus now. The sine of 300 degrees. Let's go back and look at what we've done in your notes right above this. The sine of 300 degrees itself came out to be a minus the square root of 3 over 2. So looking back down here, this is a minus the square root of 3 over 2 times this minus, which makes a positive the square root of 3 over 2. And looking back in our problem here, the sine of a minus 300 degrees is equal to a positive square root of 3 over 2. We get the same answer. Now what that says, looking back up here, is this. Rather than having to figure out the angle going in the clockwise direction, it says we can do this every time. We can just find the sine of 300 degrees and put the minus out in front. Now we work it, but we still work at the same process. We find the sine of 300 degrees. That's the sine of 60 degrees. But wait a minute now. The sine of 300 degrees, let's go back and look. The sine of 300 degrees was the sine of 60 and a minus in front of it. Because now we're talking about a positive 300 degrees. So looking back here now, the sine, this part, the sine of 300 degrees is a minus the sine of 60 degrees. But that still times that other minus. What I'm trying to get across to you is that I don't care whether you work it this way, you just go draw the angle, and then go put the related angle down here and come up with the plus and minus by the quadrant. Or you can take that minus out and do with it by whatever our rules say, and then work this part, remembering that that minus is still times that. And so we still come up with a minus the square root of 3 over 2 times a minus, which is still a positive square root of 3 over 2. Now, let's do the cosine. Let's do the cosine rule. Looking down here, the cosine of a minus theta is the same as the cosine of theta. They say that if you want the cosine of a minus 120, forget the minus and just go find the cosine of a plus 120. If you want the cosine of a minus 300 degrees, go find the cosine of a plus 300 degrees. If you want the cosine of a minus 4 degrees, go look up the cosine of a plus 4 degrees. If you want the cosine of a minus 313 degrees, just go look up the cosine of a plus 313. That's what that says, and it says that you'll get the same answer. Let's check it out. Doing the cosine of a minus 300 degrees says that's the same thing as the cosine of a plus 300 degrees. Well, what is the cosine of a plus 300 degrees? Let's go back over here. And the cosine of a plus 300 degrees is the cosine of 60. It's in quadrant 4, and therefore it's positive, and we get 1/2. Now, let's look now at tangent. I'll come back and work another one on this when we get to the next example, 120 degrees. Looking at tangent, the tangent of minus theta is the same as the sine rule. Don't write sine, it's the same concept. Tangent of minus theta is equal to minus the tangent of theta. Well, let's do this minus 300 degrees. The tangent of minus 300 degrees is equal to a minus the tangent of 300 degrees. Well, the tangent of 300 degrees, that's quadrant 4. And the tangent there is negative. So from this part, we get a minus the square root of 3. And then the other minus changes back to a plus, final answer. And that's why this comes out to be a positive, the square root of 3. Now, look right here for a moment, and what I'm trying to tell you is this. If you want to work a sine of a minus an angle, you can just go do minus the sine of, then that angle. I'm not telling you that the answer, the final answer, I'm not saying is going to be a minus. I'm simply saying that if you want to always draw positive angles, then you can do so. The cosine of minus theta is just the cosine of theta. You can just forget about the minus, and it'll have you the same answer. And the tangent of minus theta is minus the tangent of theta. Now, if you want to use that, you can. Now, you still, if you look back here at 300 degrees, right here the sine of minus 300 degrees is a sine of 60. It's in quadrant 1, therefore it's positive. That's just as fast, if not faster, than using this process. The purpose of these rules right over here are for problems where you do not know the angle and you're working with identities or this type of situation. These are used a lot of times to reduce identities or replacement for proofs in that type of situation. But I would like for you to know that concept. Now let's look at 120 degrees. 120 degrees is quadrant 2, and that happens to be 60 degrees. So the sine of 120 degrees is the sine of 60 degrees. Quadrant 2, sine is y over r, that's positive. So this will be a positive, the square root of 3 over 2. The cosine of 120 degrees is the cosine of 60 degrees. That's in quadrant 2, so that makes this negative. Cosine is x over r. And so that makes it a minus 1/2. The tangent of 120 degrees is the tangent of 60 degrees, which is the square root of 3. It's in quadrant 2, and that's y over x. That's positive over negative. That's negative. And so that's minus the square root of 3 over 2. Minus the square root of 3. All right, looking quickly at the sine of a minus 120 degrees. A minus 120 degrees is in quadrant 3. So the sine of a minus 120 degrees is the sine of 60, but it's negative because it's in quadrant 3. And so this ends up being minus the square root of 3 over 2. The cosine of a minus 120 degrees is the cosine of 60, and it's also negative in quadrant 3, so that's a minus 1/2. And the tangent of a minus 120 degrees is the tangent of 60 degrees, and it's in quadrant 3. That's positive, and so this would be the square root of 3. Now, what I want you to see right here is, look, we have the cosine of a minus 120 degrees. Remember, that's the same thing as the cosine of 120. Answer comes out to be negative. So here's an example where we have a negative angle, and the final answer comes out to be negative, even though we're supposed to have this rule that the cosine of a minus theta is equal to the cosine of theta. Just drop the minus. This is not saying that the cosine of a minus angle is always positive. It's simply saying that you can find the cosine of a minus 120 degrees to be the same as the cosine of a plus 120 degrees. It's saying that the sine of a minus 120 degrees is the same as finding minus the sine of 120 degrees. All right, let's look at the example 8 and example 9 right quick. Number 8, the 158 degrees. The only difference between this is you're not dealing with your special angles. 158 degrees is this angle, and that makes this 22 degrees. So we find the sine of 158 degrees is the sine of 22 degrees. And then we go look that up in the table. The cosine of 158 degrees is the cosine of 22 degrees. Oh, wait a minute now. We need to plug the plus and minus. Back here in quadrant 2, this is positive. Quadrant 2, x over r, that's negative. And continuing, the tangent of 158 is negative the tangent of 22. Because it's negative, quadrant 2 is y over x, positive over negative. And if you look this up, you get your decimal values there that are in your notes. All right, 305 degrees. Example 9, 305 degrees is in this quadrant, and so that makes that 55 degrees. So we have that the sine of 305 is the sine of 55. It's in quadrant 4. That makes that negative because this is y over r. Cosine of 305 is a positive, the cosine of 55. And the tangent of 305 is the tangent of 55, and it's negative because of quadrant 4. Now let's go to 2 more examples. If you'll find the examples in your notes where it has 3 cosecant square root of 45 degrees plus cotangent 150 plus sine of 300 degrees. All right, let's look at this one and do portion at a time. Let me read this off again. This is 3 cosecant of 45 degrees, that squared, plus the cotangent of 150 degrees, plus the sine of 300 degrees. What does this mean? Well, this we are supposed to already know how to work from Chapter 2. We go find the triangle and draw the triangle and find the cosecant is the hypotenuse over the opposite side. and we work that out and square it. These are the kind now, dealing with angles more than 90, that we have to work with. So let's look at the second line. Look at the next line on your notes there. If you notice, we have filled in the cosecant of 45 degrees. That's by doing this triangle bit. 45 is 1 square root of 2. Hypotenuse over the opposite side. So we have filled in the square root of 2 over 1 squared. But let's don't fill this in so fast. The cotangent of 150 is cotangent 30. In other words, 150 degrees is right here, so that's 30 degrees from the x-axis. It's in quadrant 2. Cotangent is x over y. That would be negative over positive, and therefore it's negative. The sine of 300 degrees would be the sine of 60. But the plus and minus 300 degrees would be around here. Sine is y over r. Down here y is negative and r is always positive. Therefore it's minus the sine of 60 degrees. So what I'm saying to you then is anytime you have over 9-degree angles, then you need to go through this either on paper or mentally. All right, let's look at the next line then, and let's fill in the answers. All right, we have the square root of 2 squared, which is 2, over 1, which is still 2. The cotangent 30 degrees, all right, that's where you draw your 30-60 right triangle, and you're going to have 1, 2, square root of 3, and that would be the side adjacent over the opposite. So we will have square root of 3. The minus, remember, still comes from the quadrant. All right, the sine of 60 degrees, the sine of 60 degrees is the square root of 3 over 2, the minus from the quadrant. Now looking at the whole picture at once, we have then the remaining part of the arithmetic. 3 times the 2 is the 6, minus the square root plus minus is a minus the square root of 3, plus times the minus is a minus the square root of 3 over 2. Now instead of writing a square root of 3 over 2, that's the same thing as 1/2 of the square root of 3. The reason I write it this way is because what we have is a minus 1 of these and a minus 1/2 of these, so that's a minus 3.5 of those. Then getting common denominator, you have in your notes the final answer. Let's look now at the next example. We have the sine of 240, cotangent 150, tangent cubed of minus 135, and so on. Let's look now. We have these angles larger than 90, so quickly let's look at the next line. The sine of 240 is minus the sine of 60. That's in quadrant 3. That's negative. Cotangent of 150 is the tangent of 30. I'm sorry, this should be 30. The cotangent 30, and it's negative because this is quadrant 2. Quadrant 2. Cotangent is y and x. That's negative. Dropping down here, we have the tangent of minus 135 ends up being a positive, the tangent 45 degrees. And that's cubed. The secant of 240 ends up being the secant of 60. It's negative because that's quadrant 3. Quadrant 3 is secants r over x. That would be positive over negative. That makes that a negative. And then looking at the last line, we have now fill in the numbers. The sine of 60 is the square root of 3 over 2. This minus is this minus. The cotangent 30 degrees is square root of 3. This minus is this minus. The tangent 45 is 1 cubed. The secant of 60 degrees is, I'm sorry, I'm making mistakes here in arithmetic. The secant of 60 degrees is 2. And correcting this on the screen here, this would be 1 plus 4. This would be 3 halves divided by 5, and so that final answer is 3/10. Okay? These are the numbers that you have on your notes. I just made a mistake here in the tape. But again, let's point back, looking at all this at one time, pointing back to the concept of the 240 goes to the 60 minus, and so on. All right? the tangent of 150 is a minus cotangent of 30. The tangent of a minus an angle here happens to be a positive number cubed. The secant of 240 happens to be the secant of 60 in quadrant 3, which makes that negative. And filling this in, going back through then, as you see the correct numbers, then this is the final answer. This concludes then the tape on Chapter 4.